All right, we're going to talk about dead reckoning. And this is where the nav log is going to come into play. We're not going to do a complete nav log here. We're just going to do one leg. We're not going to use any checkpoints on it. We're just going to do one leg. And this is kind of do you know how to do this sort of stuff? I have found that there's a lot of students who didn't really get that good grasp of flight planning in their private pilot training. And oh boy, once I got an instrument course, and I almost just threw all that stuff away because I'm going with iPad. And then you don't know how to use the iPad. Because there's certain errors. I see people, they try to use certain things and try to fill in the nav log, and they get numbers all in the wrong spots here, right? So we just want to make sure that everybody has the basic understanding of how to do the navigation exercise. Important for a couple of reasons. One, if you don't have an iPad with ForeFlight doing all the calculations for you, you got to do it by yourself. Know how to do it. Also, if you're going to go on to become a flight instructor, you're going to teach your student how to do navigation planning. And no, you're not going to tell your beginning student, go buy a $700 iPad and go pay a $150 subscription and let ForeFlight plan everything for you. That's not going to fly. So you got to know how to do this stuff here. So let's go over some dead reckoning. We got a discussion area for questions. I want to start with the nav flow chart, and just a disclaimer here. I have a poem. It's politically incorrect, right? I'm not trying to offend anybody with it. It's just a kind of a silly way to remember the progression of navigation log planning, right? It was taught to me by my instructor. It was back in 1990 when we never really heard of political correctness at that time. We've grown, matured a lot since then. When I tried to change it more politically correct one year, no one remembered it. So I'm like, okay, let's just go for it. So again, no offense here. All right. And the poem is that true virgins make dull company. All right. So the letters there help us understand how we flow through the navigation log. And it's kind of split into two parts. As you can see there, there's the on the ground planning part, and then there's the in the air flying part. And when you're on the ground, we always start with getting out the plotter, drawing that line between 2 points, and coming up with the true course. Okay? Hence, the first letter of our poem starts with T. The next thing that we could do is add or subtract variation, which gives us a magnetic course. And then we would add or subtract a deviation to come up with a compass course. So hence the letters of our poem help us flow through the true, variation, magnetic, deviation, and compass information. So true course, obviously, that's your plotter. You've got a course line. The plotter helps you measure that angular displacement from true north, hence the name true course. We know that the compass on board the aircraft always points to magnetic true north, so we have to deal with variation. East is least, west is best. Another little silly poem that we use to help remember. We add or subtract our variation. Of course, that gives us our magnetic course. In the aircraft, we have our electrical interference with the magnetic compass, causing it to deviate one way or the other. And so we look at the compass card to determine, well, do we add or subtract what we read on the compass? And that gives us the compass course. So that's all great for planning purposes, but up in the air, we have to take into account the wind. All that planning we do on the ground is for naught if we don't plan for wind correction. So we convert over from planning a course to flying a heading. So a true course plus or minus wind correction angle would give us a true heading. And that's kind of the normal route you take on your nav log there. You start with true course. You figure out, if you look at on the boxes there, the box below true course is for the wind correction angle. And then in the next box over is true heading. And then we add or subtract our variation. See, that box is lined up on there to give us magnetic heading. And if you're flying that Cirrus aircraft, that's where you usually just stop, because we have a magnetometer on board that reads magnetic heading for us. But what if I don't have a magnetometer system and what I'm flying? Then I'm going to be utilizing that magnetic compass, and I have to take into account the compass card deviation, and then I can fly a compass heading. So there we go with the way that we flow through the nav chart, and we're going to work through the nav route here. That's why you've got the nav log. I want to make sure everybody can do it, and then part of our group activity is going to be emphasizing certain aspects of the navigation log, making sure you understand it. Okay. So we're going to start, and that printout you brought from Harvey Lake to Silver Lake is our route that we're going to be flying. And we're going to start off with putting in our fixes. So I guess it's called Harney Lake. So we'll imagine that you and your friends have all flown your personal airplanes, and you're sitting in the middle of Harney Lake, and you heard, hey, there's something going on over there at Silver Lake. Let's go fly over there. Let's check it out. All you've got is your flight computer with you, a piece of paper with your route. So we need to come up with all the information. We don't have GPS navigation today. We don't have ForeFlight to plan for everything here. So we got our fixes down. Our first thing that we want to accomplish is measuring the true course. So you got your route. Get your plotter out. Now when it comes to angles, your plotter doesn't care about the scaling, so you can measure your true course. All right, and that will be your top hat question here. So once you get to true course, put it right in the top hat. And it's always best to use a true course measurement from a line of latitude or longitude near the middle of your route. All right, looks like a lot of you got the correct answer. 264 is correct. Some of you have got a measurement starting from Silver Lake going to Harney. So we're actually going from Harney over to Silver on this one there. Now, if you take a look at that route, okay, this is where I want to talk about something you should be doing all the time. It's called gross air check, a gross air check. Just looking at that route, you can see from Harney Lake to Silver Lake is a westerly direction and a little bit to the southwest, mainly west. A 237 direction is too much southwest on there. Gross air check would catch that sort of mistake there. Okay. These other ones, they're kind of reasonable here. 257 up to 263. Okay. The easterly directions, again, that gross air check, you do that first. You say, I've got a westerly direction that I'm flying. Okay, so we got our true course now. Next bit is to figure out the winds aloft and wind correction angle. Okay. Now the winds aloft are on there at 229 degrees and 42 knots. Your true airspeed is 100. So if you want to get those filled in, so 229 degrees, 42 knots of wind speed, 100 knots true airspeed. That's your top hat question here. Go ahead and figure out. And you're going to figure out number of degrees of wind correction angle and whether it's left or right. Yeah, we'll give you a few more seconds. Okay, so for a wind correction angle, 14 degrees. Most of you got that one correct. And then it is applied to the left. Your left of your index line. So we got 14 degrees and left correction. So a left correction is going to be subtracted, right, So that's your next question here. Calculate the true heading. So your true course, plus or minus wind correction equals true heading. A left correction goes counterclockwise on the compass rose. That's a negative. It's subtracted. So true course minus the wind correction angle gives us true heading. Some of you are a little slow out of the gate here. All right, so most of you got that answered it. 250. That is the correct answer. Our next bit's going to be to find our variation here. So using your chart, go ahead and determine the variation. So number of degrees, whether it's east or west, and do you add or subtract? Okay, remember, we're just looking at the chart here, finding the variation. East is least, west is best.
You are right.
All right. So it's an interesting one. 14.5 degrees of variation. It's getting far out west. That's how they start depicting it there. And it is an east direction. Right. And do we add or subtract? Well, east is least, so we do subtract. It is subtracted right there. By the way, in these brackets are the possible answers to fill in for the box there if you hadn't figured that part out there. Now, what do I do with 14.5 degrees? Because obviously, as a pilot, I can't fly a half degree. You either round up or down. Your choice on what you want to do with that. All right, our next bit, after we figured out the variation, is then calculate magnetic heading with it. So true heading, plus or minus the variation, gives us a magnetic heading. So 236, come around there. You notice that the tolerance is growing as we go through these calculations here. So when we started off with measuring true course, our tolerance was plus or minus 1. With the wind correction angle, we added another degree of tolerance. And at this point here, we've added a third degree. So keep that in mind. As long as you're within the tolerance here, you've got the correct answer. The next bit's going to be deviation. Since we don't have magnetometer on board the aircraft, we have to look at the compass card and read the deviation. This is what a typical card would look like on most airplanes. It might be something you have never seen before because you've never bothered to look at it, especially flying a Western airplane, right? But they are there. And the idea is if you want to fly a certain direction, let's say you wanted to fly a direction of 030, so northeast, you would actually steer the aircraft 3 degrees left. And so your deviation would be 3 degrees left or minus 3 degrees. So that's how we work it. So keep in mind, we have 235. And so we would be looking in these boxes right here. It happens that the variation or the deviation amount is the same for those, so we don't have to do any interpolation here. So if we want 235, which lies in between these two, then we can see our variation. So that's going to be your next question here, is determining the deviation. So we're trying to get a magnetic heading, 235. So how many degrees do we have to deviate, and do we go left or right? Remember, if your numbers go smaller, that's a subtraction. If they go bigger, that's an addition. Okay, so the amount of degrees is 4 degrees, and that is going to be a right correction. So if we look up on our compass card, okay, whether it's a 210 we're trying to steer or a 240 we're trying to steer, it's 4 degrees to the right. The numbers are bigger, 4 degrees bigger, so that's going to be adding on 4 degrees for deviation. All right, so your next bit is to come up with compass heading. All right. Magnetic heading plus or minus deviation gives us the compass heading. So 240 the approximate heading, 239, 240. Some of you answered, looks like you may have subtracted your deviation. Hard to say what you did. So now we know what to put for flying. You know, we fly 239 degrees on the heading indicator or using the magnetic compass. Finishing off the bits here, now we do some calculations. Next bit is the distance that we're going to be, right? We've already done this earlier, but if you want to go back and do it again, take a moment, get our tick marks on there and up against the side, counting off every 5 or 10 on that. Okay. So that's going to be your top hat question here. Okay. Measuring the distance from the center of Harvey Lake to the center of Silver Lake. Okay, down to 15 seconds. Okay. All right, so 70 to 71 miles should be what you should have determined. We're going to use 71 for our distance here. Next bit is determining your ground speed. Now you did find your wind correction angle, so you may still have that set up in your computer, but that's going to be our next bit, is determining the ground speed. So we still got our winds at 229 degrees, 42 knots, and 100 knots of true airspeed. So let's get the ground speed figured out.
What was? Yeah. Probably the medical. Doesn't tell us any of them. I thought it was the country. Eddie 141.
Okay, looks like most of you got the right answer there. Low tolerance, if you got between 62 and 64 on your ground speed, you are correct on that. I'm using 63 for the calculation. Our next bit is to figure out our time en route. Now, before I do that, I want to make sure I do another gross air check. My 63 knots, that means 63 nautical miles per hour. In 1 hour, I travel 63 nautical miles. My distance is 71 miles. So my gross air check says a little over an hour should be my answer. All right. So I always take a mental guess as to what my answer should be close to prevent any errors from popping up. So go ahead and estimate the time en route. We're using a ground speed of 63 knots and a distance of 71 nautical miles.
It's like.
All right, so most of you did get that one correct there. Someone got somewhere near an hour. That's going to be a little too short because in 1 hour you would have gone 63 miles and you still got 8 miles left on that. Now that we got a time, and so I got 67.6 and I got that off my manual flight computer, all right? If your digital one comes up with a slightly different decimal point, it won't make any difference, all right? Last bit is going to be, well, actually, we got a couple more bits here, but then we want to come up with the amount of fuel that we use. Okay? In order to do that, we have to have a fuel flow. We're going to use 4.7 gallons per hour. So 4.7 gallons per hour, and let's go ahead and calculate over those 67.5 minutes, how much fuel do we use? Gross air check says I'm flying just over an hour. My answer should be slightly greater than 4.7.
Yeah.
Right, most of you did come up with the correct answer there. Should have come up with approximately 5.3. 5.3 gallons. Okay, we're going to finish this off with 2 more bits. We need to determine our cruising altitude. In order to determine cruising altitude, we have to understand how to get that. So we're going to be needing to understand magnetic course. Now, on your nav log, we have put together 2 boxes, magnetic course and altitude. That is your reminder that magnetic course is the determining factor for your cruising altitude. Whether you're IFR or VFR, it's always magnetic course. So try to remember, those boxes are together for a reason. It's because magnetic course is determining cruising altitude. Let's go ahead and then take our true course, add or subtract the variation to get magnetic course. Remember, your variation was 14.5, so it doesn't matter if you round it up or round it down here. Okay, so true course plus or minus your variation should get you somewhere around 249 degrees. So we've got to know what magnetic course is, 249. And then we're going to apply the rule. It's actually 2 bits of this rule. Make sure you understand both bits. Okay. I'll come back to that slide. Let's see. We'll use this one. Okay. We're trying to determine our cruising altitude, and we want to make sure that we are a suitable distance above obstacles in the area. So obviously, in this example, we wouldn't be able to pick like a 3,000-foot MSL altitude. You know, you'd be in the ground tunneling your way over. Right? So we want to take a determination of the highest obstacle within a 4 nautical mile region. It's 4 nautical miles of the center line, as well as 4 nautical miles of the end in the beginning of your route. And look for the highest obstacles in there. Once we find the highest obstacle, the cruising altitude regulation says that your cruising altitudes begin 3,000 feet AGL. Okay, so 3,000 feet above the ground is where cruising altitudes begin. So we find the highest obstacle, and we simply add 3,000 feet onto it. And then figure out, well, what sort of cruising altitude are we going to be able to use? So first bit here is we're going to determine the highest obstacle. So in that little sausage area there that we kind of got drawn, take a peek. You can see that they're laid out. Several of them are laid out here. So this is going to be the next question for you. Highest obstacle within the navigation area. What is the highest obstacle within that navigation area? That's 4 miles either side of the center line and 4 miles either side of the ends. So we're not determining cruising altitude yet. We're looking for highest obstacle right now.
It's the highest for the whole.
All right, 6,143 feet. That is the highest obstacle. That's within 4 nautical miles of the center line, 4 nautical miles of the end. So determining our cruising altitude then, what would be our lowest cruising altitude possible? We need to be 3,000 feet above our highest obstacle, and we need to apply this semicircular rule. Anything from 0 degrees through 179 degrees of magnetic course is an odd thousands plus 500. And 180 through 359 degrees is even thousands plus 500. Again, we're using magnetic course. So for this problem, determining the lowest possible VFR cruising altitude, we're taking our highest obstacle, adding 3,000 feet to it, and then go to the next highest cruising altitude, appropriate for your direction of flight. So 6,142 feet plus your 3,000. Go to the next highest VFR cruising altitude for your direction of flight. All right, a couple more seconds here. All right, let's see what we did here. So 10,500 feet. There we go. That would definitely work. Now 6,500 feet, that would only get you a few hundred feet above that obstacle. It's not 3,000 feet above the ground. So that 6,500 would not be a cruising altitude. Cruising altitudes are beginning 3,000 feet AGL. There we are with our nav log completed. You got questions? Using electronic flight bags. Why is there not more emphasis on how to use an EFB? Students using them incorrectly. That's your instructor's responsibility to make sure you know how to use it. Right? Does your instructor know how to use an EFB? That's debatable. Right? A lot of students say, okay, Mr. Miss or Mrs. Instructor, I've got my iPad. Make me EFB approved on my PQ card. There's a lot of basics that you do need to know about, and you're right, we have not emphasized that in here. So we'll see if we can do something about that. All right, any other questions? All right, I'll tell you what, we'll take a quick break. Why don't you take a 5-minute break? When you come back in your groups, please.